So yeah, like I said, with brute force problems, like when I review them, there are just like these like little pointers and things that I just never I wouldn't have known about. It's only the first time that you see them that you kind of like, oh, here's kind of the trick. So for example, like with this minimum number list, um, basically you need I forget, I guess you need like an initial kind of like starting value. Uh, so we'll say like here's my minimum. Because the idea is find the minimum element in this list. So you want to start off with the minimum element, and then what would your minimum element be? Okay, so we'll think about it. If we're gonna do brute force, and say we choose a number like 0, and then we like say, okay, for element in elements, this is wrong by the way. We'll fix this. But for element in elements, if the element is less than the minimum element, what do we want to do? Make it the new minimum element, right? If my current element is less, if my like local min, and maybe this is a better way of putting it, this is my global min. You kind of think of that. This is like a normal idea that you have this like kind of global min, like meaning your minimum for the entire data set. And you could say like, you could almost call this like your potential minimum element, but we'll just call that global min for now. So set our global min to 0, and we say, let's say we do like for element in elements. If the element is less than the global min, then the global min is going to equal, we're going to reassign the global min to be that current element, right? And then finally, when we're done going through all the elements, we'll return the global min. Okay? Now this is going to be wrong. Why? Because if we choose a number 0, it's less than every number here. So what's going to be, so this is never going to stop being my global minimum, right? Because I'm going to go one by one through each one of these, and every single time it's going to be like, well, this is bigger, it's not going to work. So if we do this, right, the minimum is going to be 0. So what's a good number to choose? Well, something that actually we want the opposite, right? We want a number that's going to be automatically bigger than every element in the list. So the different ways you can do this, like one way you can do this is just say, all right, give me something that's larger than every other element in the list. So you could do like max of the elements plus 1, right? That would be an option. Another thing you can do is and this is what I'll typically do, is do float. You do float and then string infinity. So you'll just set the minimum, right, this global min, to when you start off, as a number that, right, even if this was a bunch of thousands, obviously infinity is going to be larger than it, right? So we'll set it to be, and this is why I would need to like not be rusty, because I never use this. Like I rarely, like I don't know how many times day to day I ever use this. So I would have to look this up. But right, this is kind of the approach. So set the global min to like this initial number that's that's always going to be exceeded, and now you can kind of see how this is going to go. The first number is obviously going to be less, right? Then the second number is going to be less. This one's not going to be, right? So we can print like current min is, and we'll say like the element, comma. And it's good to just know how to do some logging, right? So like a print statement with the comma, that way we can add in the string. You can now see how this goes. So we start off as 1,000, right? Then we finally hit my 64. The current min is 64. Then we get to the next number, 39. So that takes my if statement. It's 39. And then we just basically keep on going until we get to 36. And then that's going to be the last current min. And when you get to the end of the loop, your current min becomes your global min, right? Like the min throughout the data set. You could do that too. Like Conwell's like, what if we just did elements of 0, like just arbitrarily set it to be the first element, right? That works too. Yeah, this works fine as an initial element. you kind of, so yeah, we saw kind of a couple different strategies. Max, I'm guessing with the thought with, the reason why maybe you think max is not the best, right, if we did max of original lists, is, well, how is Python finding the max of this list? Well, it has to go through every single element, right? So this has a cost of n. So yeah, it's faster to either just initialize it as, infinity, or, right, this also works. You can do original list of square bracket 0, just arbitrarily set it to the first element, and then we know that, fine, this is the min, currently, but we know we're going to move through all the rest of them, and that'll be reset. And we get the same answer. So this works fine. And by the way, this has a cost of n, which is not expensive. N meaning how many operations is it? Basically, our loop just goes through once for every element in the list. In doing that, n is fine. N squared, not fine, right? But n is fine. All right. Finding uniqueness. For this one, and this is like a typical thing, you should feel comfortable like with uniqueness. We can just quickly do it. I would just call this just create a list of scene elements. Okay, so we'll go through the elements one by one, and we'll say like for element in elements, and then we'll just say like, append in, just always for every element, we'll add in my element, right? And we'll say, okay, I've seen this guy. And then the other thing you can do is basically, now we just need an if statement that says, I'll do this, if element in scene elements, then we'll return false, okay? Because it's not all unique if I see an element I've seen before. And then at the very end, if I get to the end of the loop and I don't exit out of this, right, then I can return true. Okay? So in this case, where we'll have seen an element before, I wonder if there's a way, I'll just print the element. Seen element, this guy. Okay, so it saw the element 52 before, I guess. I don't know where. Oh, there it is. Right? So it broke. One gotcha here is just remember, if you do scene, you just have to be careful where you put the scene elements, because let's say we say for element. Oh, what am I doing? Oh, if element is in the scene element. So we go through all the elements one by one, and then let's say we append it up top here. This is going to break, or it's going to return false right away. Why? Because we initialize it as empty. We go through all the elements. We then do scene elements dot append the element. So I'm appending the number -78, and then still on this element, I'm saying is -78 in my list, and it is, right? So it's always, we have a bug essentially, because we're looking for that same current element. So you can see this will give me that -78. So you just have to make sure that I don't say I've seen this guy until after I do the check. All right. Once I've done the check, then I can add it, and then the next time around, when we see that duplicate, it will properly exit. Well, other things you just want to be careful about is your indentation. Obviously, with this stuff, it's a good reason why you'll probably make mistakes, and you just need to have those logging skills, debugging skills, etc. All right. It's also a good reason why talking out loud is good, because then your interviewer can see what you're doing and help you fix typos. Lots of times they'll help you fix typos as they see them come up. All right, reversing a list. I did want to go through this. This is kind of another kind of brute force technique that comes up a lot that I just wouldn't, it's not something I do every day in programming, and that's called the swap. Okay. So let me just show you what I mean by the swap. This comes up a lot in LeetCode problems. So what I mean is, let's say, we want to reverse this number with this number, right? The first element with the last element. Okay? How do you do that? we'll do original list of 0 equals original list of -1. Okay? So that will say that I'm going to think about what that does. That sets my first number, right, as 2. Okay? But what happened here? Like I lost my 7. Right? I said the first element should equal the last, but I also want to say that the last element, this 2, should equal the first. So how do you do that? What you can do is actually do this kind of like swap, and the way it looks is you'll do original list of -1 equals original list of 0. Okay, so this is a swap. And what it's doing is really like two operations at the same time. You're saying this first element equals the last element in the list. So 7. So this will be like 2 is the first element in the list. And then you're also saying at the same time, the last element, what do I want to set the last element to be? 7. All right. So this is my swap. The first element, the first shall be last. The last shall be first. Okay. So now why does this work? Well, it works because in reversing a list, I can kind of move backward. Like now I'm starting to, you can already see I'm starting to do it. 2 and 7, and then I want to work inwards. So if I increment this, if I make this now index 1, and this guy index -2, right, and swap those two, then I'm going to have 5 and 2, right, which is correct. And then I keep going inwards. So let's now do it. Oopsies. Let's do this. So I'm going to say for I, the index, in, and we'll just do this. We're going to do length of range of original list. And this is wrong, by the way. We'll see why. And then we'll swap it, and then we'll also print out so we're going to go through each element. I'll just do this for now. You go through each index in the length, right? So 0 through the length of the list, right? And for each element, we're going to swap it. So what does that mean? It means this should be I, right? It shouldn't be 0. It should be I, right? And this is tricky. It shouldn't be -I. That would be wrong, right? It should be -1. So what would -1, right? Because if it's -I, that's -0, which is just 0. So you're going to swap 7 with itself. You want to get to this value. So that's -1. So I'm just going to put like negative index. And what does that equal? That equals I, so this is 0, right? Plus 1 times by a negative, right? The negative of this. And just make sure this works, right? So the first time around, this value is 0, and I want this to be -1. The second time around, right, the second iteration, the I will be 1, and I want it to be -2, right? So this seems to be good. So now I'll just say negative index. And here we'll also say negative index. Okay? And now I've implemented my swap. We just have one issue, which we'll see, I guess. Which is, all right, let's just see it. What am I doing? For I in length. Oh, this needs to go out this way. Sorry, gang. Range, length, negative, this guy. So this is the length. This is the range. I'm reversing the list. I need to return my value. Let's return it. Return the original list. Yeah, I think I messed it up worse than I thought. Oh, here I have a 0. This is wrong. Sorry, again. This is my I. Okay, yeah, hold on. Let's get back to my original list. And now I'll do it again. Okay. So notice we did not change the value. Everything's as it was, as it started. The reason why is because what I did, and we can see this, we'll print this, print the first element, and then print the last one. Why does it not like this negative index?
You're spelling with it without the E. You need the E and the index.
Thank you.
Yeah, there you go.
Okay, so you can see what's happening here is that it's doing 7 2 2 5. So it's doing this properly. 7 2 2 5 4 3 6 3. But then it's doing it again basically. It's doing it twice. Right? And the reason why is because I'm going through this, doing this once per every element. But I don't need to because, how many times do I need to do this? I'm eating my way in from both sides. So I only have to do this half the amount of times. I only have to do, right? A swap takes care of two elements at the same time. I'm basically swapping it, reversing the list, and then unreversing the list, right? Swapping that reverse list so that I'm back to the original. So that's what's going on here, right? You can see I'm swapping, and now I'm kind of unswapping it. So what we should do is say only half the length of the original list. This is also going to break. The reason why this is going to break is because the length of the original list divided by 2 is an integer. Is a length of the original list. Sorry, I need to do it like this.
Let's see.
Yeah.
Yeah.
Right, this is a float, and it's going to tell me that you can't use a range with a float. The other issue is that, let's say this list was odd, right? I would want it to be, I'm not going to want to swap it, right, 3.5 times. First, that doesn't make any sense, right? But second, it's actually okay that I'm only swapping, if there's 9 elements here, that I only perform the swap 4 times. That's fine because this middle element doesn't need to be swapped, right? It stays in that center. We just swap these elements and keep this guy as like a pivot point, I guess. So what we can do instead is use this floor operation, the double divide assign, and that will say this value this is 9, right? This gives me 4.5. The floor will round down to 4, okay? Which is what you want. So these are all these little gotchas that you learn because of LeetCode. This is why you have to practice this stuff. And now we've properly said we're only going to do a swap half the amount of time, right? We cut that in half. We did the floor. And now I think this actually worked, even though I changed the data structure. But you can see we started, right? The 1 is now my first element, right? 2, right? So this looks good. Anyway, if this felt tricky to you, practice this, right? Like I said, I don't think we've ever done like a swap in a class. I don't know the last time we used this, if ever. But this is the type of like small things that come up in LeetCode problems all the time. You just have to have seen them before, have messed it up before, and have fixed it. With slicing, I think it's fine for you all to share other solutions on these too. So this is what Chris had. Is this I think this might be the element. Oh, I see. I think this is, I kind of get what he's doing. He's reversing it this way. So I think it's like taking this element, and we're going to see something like, this is another way to do a swap, I believe. So I think this will work, but we're going to see this in the next class. So this is one way to do a swap that we just saw. I'll post the solution. The solution is there. Like I said, if you had problems with this or this feels confusing to you, go through it. it's better to go through it now than on an interview, right? So just do it.